The constant multiple rule says that if u of x is a differentiable function and c is a constant, then the derivative of c times u is c times the derivative of u. What it's saying is if I have a function times a constant, that its derivative is the constant times the derivative of that function. For example, in our last video, we learned that the power rule tells us the derivative of x squared is 2x. So if I wanted to take the derivative of 5x squared, well, my derivative would be 5 times 2x is 10x. So I see that I can use the power rule with the constant multiple rule. Let's do another example. Find the derivative. So let's say I had f of x equals 100 x to the third. F prime of x is. Well, I know that I could take the derivative of x cubed by saying its derivative is 3x squared, and then the constant multiple rule says, hey, multiply that by 100. So if I put the constant multiple rule together with the power rule, I have 3 times 100 is 300 times x squared. And so there's my constant multiple rule along with my power rule. All right, well, my constant multiple rule, pretty easy to use and understand. Let's make sure we believe it. So I have a function u of x, and I can take its derivative. So that tells me that du dx exists. I want to find the derivative of c times u of x. Well, that would be the limit as h approaches 0 of h over c of u of x plus h minus c times u of x. This is the function I'm taking the derivative of, so I have that function with an x plus h in the middle. I have that function with an x in the middle. I see that both have a c, so I can imagine factoring out a c. Well, this is a limit, and one of my limit laws was that I could pull a constant out front. And after I have that constant in the front of my limit, what I see is this limit, which is simply the difference quotient of u, the limit as h approaches 0, that's exactly du dx. This proves the constant multiple rule. The derivative of c times u is c times the derivative of u. That's the beautiful thing about this limit definition. Now that I've proven this rule, every time I have c times a function whose derivative I know, I get to just use this rule. Now, one thing that's important to realize, I still need to understand and be able to use this limit definition, because what if I don't know the derivative of u? I give you some function you've never met before, we'll actually have to evaluate this limit first. All right, more videos and more rules to follow. At the end of every rule, I'm going to try to do an example where we put all the rules we know so far together.